GKW Physics. I'm Mr. McConnelly. We're going to talk about circuits today. But before I really get into the discussion of what I have on the board here, I have to make you familiar with a few of the symbols in order so that you can draw circuits. Now these can be found on your reference table under circuit symbols, as you would expect. And I'm just going to run through some basic ones. And I'm going to present them in a full circuit diagram. Okay? So if you had a full circuit diagram, the other day we did a series circuit, so let me just draw a series circuit. In a series circuit, you might find something like this. Let's put a here, and I'm just trying to use a bunch of different ones. Let's use this one here. And let's throw this on here. Now in your reference table, they show individual symbols, but they don't show them all put together in one diagram. So I wanted to put it together in a diagram, kind of help you digest what's going on. Now if you follow along in your reference tables at the same time, you'll realize that this symbol right here is a battery. So here's our source of the voltage. This symbol up here is a resistor. Now resistors can mean a lot of things, but sometimes you have resistors just to slow down the flow. Other times you have resistors because this is like a heating element, like an electric heater. And other times the resistors look more like this one, and this one is the circuit for a lamp or a light bulb. So when you have a resistor and you put a circle around it, it kind of almost starts to look like a light bulb, and that's what it represents. Now this V with the circle around it means a voltmeter. And voltmeters are obviously measuring potential, and we learned the other day that voltmeters have to be hooked up in parallel. So you can see that if you follow my finger here, this is one continuous connected series circuit, while this is a little branch. It's like the electricity gets to here, and it could keep going straight, or it could go this way. When you have a point where electricity can go two ways, now you call that part parallel. So that's parallel. The voltmeter's hooked up in parallel. You come around the corner, you got your switch, which looks like a door that's ajar. Now, if the switch is in the open position, right now this switch is open, is the electricity flowing through it? No. In order for the electricity to go through it, you have to be in the closed position. And when you're closed, now the electricity can flow through. So that's a switch. This is an ammeter, which measures the flow of the electrical current, the electron flow. And that has to be in series, because remember in our circuit that we set up, we actually disconnected one of the wires when we put the ammeter so the electricity would go right through it. And then this one down here is your variable resistor. And I guess the best way to think of this one is a dimmer switch, or a volume knob on your radio. If you have a dimmer switch in your dining room, above your dining room, for your dining room light or whatever, you could, if you're having a dinner which is more formal, you might like dim the lights down a little bit. If it's just a family dinner, you might leave them brighter, for instance. Maybe you have that in your house. Well, that's the symbol for a variable resistor, because you're varying the flow, and you can control it with a knob. The other example, like I said, is the volume on the radio. As you open it up, when you turn up the volume, you're turning down the resistance. You're allowing more electricity to go to the speakers. So I hope this helps you kind of get a grasp on how you actually draw the symbols in a picture. And the other thing I want you to note is that I didn't do it with a ruler, but I really should have. These lines are supposed to be straight with a ruler, and they're supposed to meet at 90-degree corners. So some of you want to just run your wires kind of like what a wire looks like. You know, wires are generally kind of, crooked and just kind of, move their way around. Well, that's not actually the way you draw it. When you draw it real straight. And I would advise that when you draw it on the regions, you use a ruler. So that's drawing some pictures, but that's not really what I'm after today. what I'm really after today is talking about circuits. And there's two really general types of electricity that you have to be familiar with. First of all, AC/DC. And I drew the little lightning bolt because, you know, like the band AC/DC. And the band AC/DC came up with their name because they were looking at a sewing machine in a store, it might have been Kmart or Sears or something, and they looked at the back of the sewing machine and they saw that written just like that, with a lightning bolt in between, and they're like, that's cool. That's a really cool thing. Well, what does it really mean? Because what it really means is alternating current, direct current. So alternating and direct current. I'm going to get rid of this marker, it's fade now. So you got alternating and direct current. Now in high school physics, we're going to spend all our time on the direct current side. Alternating current is what you find in the outlets of your home. The wiring of your home is alternating current. What it means is that the electricity alternates direction. It goes this way, and it keeps switching direction. Actually, 60 times per second, it switches direction. So alternating current is 60 hertz, but we're not really spending much time on that, so I just want to give you a real basic, and we're going to move on to DC. So under DC, direct current, there's two ways that you can wire things. You can wire them in series, as we've seen with the ammeter, or you can wire them in parallel, as we've seen with the voltmeter. So you might want to leave yourself a little example here to remind yourself. This was the voltmeter, and this one was the ammeter. Well, when you wire things in series or parallel, there's a certain set of rules that accompanies each type of wiring. And these sets of rules are nice because then you can just look at a circuit and you can apply the rules and you can figure out what's missing. So like if I don't give you some of the information, you can use these rules, apply them to the circuit, and be like, oh, I know this must be this because of this rule. So let me spell out the rules for you. And the way I'm going to lay these notes out is I'm going to give you the rules here today just for series. And when we do another lesson tomorrow, I'm going to give you the same set of rules, and I'm going to have them so they're matching so you can see, oh, for series the rule goes like this, for parallel the rule goes like this. So I'll try to write them side by side, but for today we're just going to focus on the series side. So, the first category I'm going to talk about is total resistance. If you are in a series circuit and you want to know the total resistance, all you have to do is add up each of the resistors that appears in that circuit. And I put dot, dot, dot because you could have an unlimited number of resistors. But I'm going to add up all the resistors, the resistances of the resistors. So 5 ohms, 4 ohms, and 1 ohm. 5, 4, 1, 10 ohms of total resistance. Okay, you just add them up. The next category is total current. Now, with total current, and we've already seen some of these, but in my next video I'll show you again on another demonstration. But total current, if you check the current in a series circuit, any place, if you move the ammeter around, it always reads the same thing. Therefore, the rule says no matter where you check the current, I1, 2, 3, 4, wherever you look at it, they're all equal. The next rule is for total voltage. And total voltage is almost exactly the same as total resistance. Basically, if you say, oh, the first resistor is using 5 volts, and the second resistor is using 5 volts, and the third resistor is using 1 volt, and you add them up, you will have the total voltage. 5, 5, 1, 11. So you can add up the total voltage. And then what always works is what we call Ohm's law that we learned the other day. And Ohm's law in your reference table is R equals V over I. it applies to all these series circuits. But what I want you to note is that you can apply, so it's like the total resistance is the total voltage over the total current, or you could be like resistor number 3 is voltage number 3 over current number 3, but you can't mix them. You can't take the total voltage and the current on number 3 and expect to get a right answer. If you're saying all of these are total, you can use them that way. If you're saying all of them are number 3, you can use them that way, but you can't mix and match. Okay? So these are the 4 basic rules that we're going to talk about for series circuits for today. If you stop back to my next video, you'll be able to see the demonstration of how these apply. Physics.